Welcome to the Deep Dive. We're here to break down complex topics, find the key insights, and bring them straight to you. Today, we're diving headfirst into a market that's not just growing, it's really exploding. Advanced materials for 3D printing. Our whole deep dive today is built around this one really comprehensive source. 3D printing materials market. Global growth projections to 2033.
So, our mission. To unpack the, frankly, staggering numbers and trends in this report, we want to show you just how fast this market's expanding and, crucially, what it means for manufacturing, design, well, pretty much everything in the near future.
That's spot on, because these aren't just, dry statistics on a page. They're really the pulse of a major industrial shift. These numbers, they're powerful signals of a transformation that's not just happening, but actually picking up speed, is really set to redefine how things get made globally.
Absolutely. Let's maybe kick off with the big picture, the scale, because the global growth numbers here are, well, astonishing is putting it mildly. Get this. In 2021, the whole market was valued at just under $1 billion, maybe $944 million roughly. But here's where it gets kind of mind-bending. By 2025, so pretty soon, it's expected to almost double to over $1.7 billion. And if you think that's impressive, just wait. By 2033, this market is projected to shoot past an incredible $6 billion.
Wow.
Yeah, we're talking more than a six-fold increase in, just over a decade.
And the key thing there, the really compelling part, is the rate behind it. That's a compound annual growth rate, a CAGR of 16.7%. Now, just for context, 16.7% isn't just strong. It signals really sustained, robust growth. It tells you these advanced materials aren't some small niche anymore. They're being woven into all sorts of sectors. It shows a real fundamental confidence shift in industry. This isn't, some speculative bubble. It feels like a foundational build-out.
Okay, so we've got this picture of just massive global acceleration. Let's zoom in a bit now because, yeah, the whole world's buzzing, but some regions are really setting the pace. It gives us clues about where 3D printing is making the biggest waves. First stop, North America. A major engine, right? Projected to climb from just over $300 million back in 2021 to nearly $2 billion by 2033.
Yeah, and what's really interesting about North America is how the growth isn't perfectly even. The U.S., as you probably expect, leads the pack. It's heading towards, over $1.5 billion by 2033. But then you look at Canada, its individual growth is actually quite breathtaking. It jumps from about $48 million to nearly $350 million.
Wow, that's a huge multiplier.
It really is. That kind of surge suggests maybe a smaller starting point, sure, but significant new investment hitting now, perhaps driven by, aerospace or medical devices, sectors that really benefit from lightweighting and custom parts.
That makes sense.
And Mexico, too, while starting smaller, is steadily growing its share. It just shows this transformation has broad appeal across the continent.
Okay, let's hop across the Atlantic. Europe, also showing really solid expansion. Their market's set to hit over $1.5 billion by 2033. Strong CAGR, too, over 16%. And Germany is the clear leader there, right? Quintupling its market from around $48 million up to almost $285 million.
Yeah, Germany's position really points to its deep roots in high-precision automated manufacturing. They're integrating it seamlessly. But Europe's story isn't just industrial strength. When you see France heading towards, say, $230 million, or Italy hitting over $170 million, that often reflects specific policy pushes, too, maybe around sustainability. Europe's focus on the circular economy could actually be speeding up 3D printing adoption as companies look for greener, less wasteful production.
That's a great point. Okay, now, here's where the story gets really interesting, I think. Asia Pacific. This region isn't just growing. It's absolutely surging. It's flagged as one of the fastest growing markets. Revenue projected to just skyrocket from about $246 million in 2021 to a massive $1.7 billion by 2033.
Wow.
And a CAGR, an eye-popping 17.5%.
That really signals a potential shift in, global manufacturing leadership. It's quite profound. China, of course, is a huge piece of that projected near $600 million by 2033. But for me, the really remarkable story is India.
Ooh.
Yeah, India's showing a blistering TGR, almost 19.5%, growing from just under $40 million to over $334 million. That's not just adopting tech, it feels like a strategic move towards high-value advanced manufacturing, moving beyond just made in India to innovated in India.
A real step up.
Exactly. And you add in Australia and Singapore, both showing over 18% CAGR. It's clear the whole region sees 3D printing as, a cornerstone for the future.
So beyond these, let's call them powerhouses, we've got some really promising rising stars too. South America, the Middle East, and Africa, they're also making pretty significant contributions. South America, for instance. The market there is set to expand more than 7 times over, from around $55 million in 2021 to almost $400 million by 2033.
7 times, wow.
Yeah. And Brazil's really leading that charge, growing from nearly $25 million to over $173 million. Argentina, Colombia, also impressive. Cheb's over 17%, both heading past $80 million.
You know, that South American expansion is really telling. It shows how the benefits of 3D printing, like complex shapes, less waste, faster prototypes, are catching on even in developing industrial economies. It suggests maybe a bit of a leapfrogging effect, skipping some older methods straight to the latest tech.
Interesting. And what about the Middle East? That region's showing incredibly strong growth, too. Set to expand from just over $31 million back in 2021 to nearly $223 million by 2033. That's a CAGR over 17.8%. And the UAE really stands out, doesn't it?
It does. Their CAGR is even higher, just over 19%. They're heading towards almost $41 million by 2033.
And you've also got Egypt, Turkey making big gains, plus Saudi Arabia, Qatar.
Right. And the Middle East growth, particularly in the UAE, it really points to an aggressive push for economic diversification. These countries are actively investing in high-tech manufacturing, trying to reduce reliance on oil and gas, building future-focused industrial parks, attracting talent. They see advanced manufacturing as critical for long-term stability and innovation. It's a very forward-looking play.
Okay, last but not least, Africa. A continent sometimes overlooked in these tech discussions, but it's starting to harness this too, showing real promise. Projected to grow from roughly $36 million in 2021 to over $216 million by 2033. Still a robust AGR, nearly 16%. Nigeria and South Africa seem to be the key players there, together accounting for almost $183 million by 2033.
So if you pull back and connect all these regional snapshots, well, it's undeniably a global shift in how things are made. The numbers tell a story. It's about a profound change touching manufacturing everywhere, democratizing complex production, enabling customization like never before.
Which brings us to the big question.
Right.
So what? What does all this actually mean for you listening right now? These aren't just numbers for analysts.
Exactly. The forces driving this, the source highlights things like demand for efficiency, for lighter parts, for customization. These are very real-world needs. This isn't theory. 3D printing tech is literally transforming how things are made and designed right now, all over the world. Think about aerospace. Every gram saved matters hugely for fuel. Automotive, lighter, stronger car parts. Healthcare personalized implants. Prosthetics designed just for you. Even consumer goods allowing for rapid design changes, maybe even bespoke products. It's fundamentally changing the journey from idea to the product in your hand.
Right. So just to quickly recap, the global advanced materials for 3D printing market is seeing really exceptional widespread growth. We've seen particularly strong momentum, almost a sprint really, in Asia Pacific and the Middle East, which signals their strategic focus.
And that truly underscores how foundational these materials are becoming for the future of making things, which, raises a pretty big question. How will our everyday products be made in the maybe not so distant future? From our shoes to our phones.
Indeed. And that's something for you to think about. As you go about your day, maybe consider the familiar industries around you. The car you drive, the medical tech that helps people, even the stuff you buy weekly. How might they be fundamentally reshaped by these 3D printing advances in the next decade or so? What new opportunities or even challenges might this rapid growth create in your own life or in the fields you care about? Definitely something to mull over.
Welcome to the Deep Dive, your shortcut to being well-informed. Today, we're really diving into the transformative world of advanced materials for 3D printing. It's a sector that's not just growing, it feels like it's accelerating. With some really surprising innovations coming through. Our mission here is to unpack the key insights from our source material. It gives a really comprehensive look at the global demand drivers, some of the challenges too, which are often overlooked, and the very exciting future trends. It's all based on solid data and research. Okay, let's unpack this. So maybe starting with the drivers. What's genuinely fueling this revolution in 3D printing materials? I think one of the biggest forces has got to be the expanding industrial adoption of 3D printing itself. It's like not just for rapid prototyping anymore, is it? Industries like aerospace, automotive, healthcare, they're using additive manufacturing now for, complex, low-volume, high-precision production.
Exactly. And that's a huge paradigm shift, really. What's truly remarkable isn't just that industries are adopting it, but, the fact that aerospace, for instance, is now creating actual load-bearing components. That was almost unthinkable just, say, 5 years ago. And that shift is driving demand for very specific kinds of materials. We're talking high-performance polymers, reinforced composites, metal powders.
Right.
These aren't your everyday plastics. They're crucial because they offer the kind of extreme strength, the thermal stability, the accuracy you absolutely need for mission-critical parts. Think components inside an aircraft engine or a medical device that actually goes inside the human body. Stuff where failure is just not an option.
So it's really about making the actual final product, not just a quick model. And speaking of those final products, that kind of leads us to the second powerful force, doesn't it?
Yeah.
The increasing demand for customization and also lightweight components. 3D printing just seems brilliant at creating those really intricate geometry-optimized parts, things traditional manufacturing, well, it just struggles with.
Yeah, it excels there. And it's incredibly valuable because it allows for completely tailored solutions. Think about, say, patient-specific implants in healthcare. They can be perfectly designed, printed to fit an individual's unique anatomy. That often leads to much better outcomes.
Right.
Or in consumer tech, creating ergonomic wearables that fit just right, making them more comfortable, maybe perform better. And in aviation, well, the ability to produce lightweight structural parts for aircraft interiors, that's a huge deal.
Why is that so critical?
Because reducing weight translates directly to better fuel efficiency and lower emissions. That's a critical factor for airlines, obviously.
It makes total sense.
Yeah.
Better, lighter, more precise. And the third major driver then that sort of ties all this together seems to be this explosion in R&D investments in material innovations. You've got leading chemical companies, innovative startups, top research institutions. They're all pouring resources into developing the next generation of these materials.
Absolutely. And if we kind of connect this to the bigger picture, this R&D is truly pushing the boundaries. We're seeing things like graphene-infused thermoplastics. These add incredible strength without adding much weight at all.
Wow.
Or biocompatible and sterilizable resins, specifically designed for medical devices. Some of these new resins, interestingly, can now mimic the stiffness of actual bone.
Really?
Yeah, it's opening up entirely new surgical possibilities. And then you've got new recyclable or eco-friendly composites meeting modern sustainability standards. This constant innovation, it's expanding applications into entirely new areas, sometimes quite unexpected ones, like construction, fashion, even personalized food technology.
Food. Okay, that's definitely pushing boundaries. But here's where it gets really interesting, because all that growth, while it's exciting, it's not without its bumps in the road. Let's maybe talk about the challenges, the hurdles in this advanced materials market. A significant barrier, I gather, is simply the high cost of these advanced materials. Is it just the upfront price?
You're absolutely right. It's often the first thing people notice, but it's more complex than just the initial price tag.
Yeah.
Engineered polymers, high-grade metal powders. Yes, they often cost significantly more than your conventional manufacturing materials.
Okay.
But the complexity really deepens when you factor in the whole life cycle. Specialized handling, maybe specific storage requirements, often intensive post-processing steps like heat treatments or surface finishing.
Right, it all adds up.
Exactly. It all drives the total cost up. And this creates pretty significant entry barriers, particularly for, say, small and medium-sized enterprises, SMEs.
Uh-huh.
They might want to adopt 3D printing, explore these materials, but they're limited by budget. It also restricts using these advanced materials in projects where cost sensitivity is, the main concern.
That makes perfect sense. And then you've also got the challenge of material compatibility and processing limitations. It's not like any material works with any printer, is it?
No, not at all. It's definitely not a one-size-fits-all situation.
So if I'm a manufacturer, what kind of headaches does that mismatch cause?
Well, it adds a significant layer of complexity, for sure. For example, certain high-performance polymers might just not withstand the thermal demands of FDM printing, that common method where plastic filament is melted and extruded.
Okay.
Or some technical ceramics, they might require highly specialized sintering environments after printing to achieve their final strength and properties. We're talking about baking them at extremely high temperatures.
Right, specialized ovens and things.
Precisely. And this often means investing in expensive, specialized equipment, and you need highly skilled labor to operate it and manage the process. It adds significant operational complexity and cost to the whole workflow.
Got it. And especially when you're dealing with highly regulated industries, there's another major hurdle you mentioned. A lack of standardization and, crucially, regulatory approval.
Yes, that's a big one.
How does that bottleneck really impact the speed at which we see these cutting-edge materials actually get used in critical systems?
Well, it creates a necessary, but, a very real slowdown. Sectors like aerospace, automotive, healthcare, They operate under incredibly strict regulation.
Understandably.
Right. They often demand expensive, rigorous testing and certification before any new material can be used in production parts. Think about the number of tests an aircraft part needs to pass. It's exhaustive. So this process, while crucial for safety, significantly slows down the rate at which cutting-edge materials, no matter how promising they might seem on paper, can actually be integrated into safety-critical systems. Innovation on the material side can sometimes outpace the ability to get it approved and adopted in these fields.
Unnecessary friction, perhaps. But okay, let's shift gears now. Let's talk about the exciting trends that are currently reshaping the market, pointing us towards tomorrow's manufacturing. First up, there seems to be a really strong shift happening towards sustainable and bio-based materials. Why is that becoming such a prominent focus right now?
Yeah, that's a major area of focus, and it's driven by a few things converging. It's not just about meeting green certification requirements or corporate ESG goals, environmental, social, governance.
Right, the corporate responsibility angle?
Exactly. But there's also increasing consumer demand for sustainable products. People are asking for it. So we're seeing specific examples really gaining traction. Things like recycled polymers derived from post-consumer waste.
Okay.
PLA blends, those are often derived from renewable resources like cornstarch. And various biodegradable resins. These are appealing because they can offer reliable performance for a lot of end-use applications, but they do it while minimizing the environmental footprint.
That's super cool and good to hear.
Yeah.
And it's not just about being green, though. There's also this fascinating development you touched on, multifunctional and smart materials.
Yeah.
It almost sounds like science fiction. What does that actually mean they can do?
Well, what's fascinating here is how these materials are kind of blurring the lines between the object itself and its function. We're talking about substances that aren't just passive structures. They actually respond to external stimuli.
Like what?
Well, for instance, imagine 4D printed objects. That's 3D printing plus time. They can change shape or function when exposed to things like heat or moisture. They could potentially self-assemble or self-repair.
Wow, okay.
We're also seeing conductive materials being used to embed sensors directly within printed parts, so you get smart devices without needing to add separate electronics later.
Integrated intelligence.
Precisely. And in medical applications, think about antimicrobial coatings that can be directly printed onto the surface of a device, which could drastically reduce infection risks in hospitals. These innovations are massively expanding what's possible, really blending material science with digital fabrication in completely new ways.
It really opens up the imagination. And finally, you mentioned we're seeing this huge surge in metal and ceramic 3D printing, moving way beyond just plastics now. Which sectors are really benefiting most from this, and what are the technological improvements driving it forward?
Yeah, this growth is particularly noticeable in sectors where you need, well, exceptional properties, like aerospace, defense, and also dentistry. Places where high-strength, durability, heat resistance, and complex geometries are absolutely paramount.
Makes sense.
High-strength metals like titanium alloys, Inconel, which is a nickel-chromium superalloy, and various technical ceramics, they're really gaining significant ground. And this surge is being driven by some key technological improvements in the printing processes themselves. Things like powder bed fusion using lasers or electron beams to melt metal powder layer by layer with incredible precision. And also binder jetting, where a liquid binding agent selectively joins powder particles. This is great for intricate metal or ceramic parts, and often faster. These advancements are now offering the kind of accuracy, the repeatability, and importantly, the throughput needed for truly scalable industrial use.
So it's becoming a real production tool.
Exactly. It's fundamentally transforming the perception of 3D printing. It's moving from what was often seen primarily as a prototyping tool into a robust, reliable production method for demanding applications.
So what does this all mean? When you put it all together, the overall picture seems pretty clear. The advanced materials market for 3D printing is just brimming with immense potential. As industries increasingly prioritize things like customization, sustainability, and higher precision in their manufacturing, well, these materials are definitely going to be the backbone of innovation across just about every sector you can imagine. And just to note, all these insights we've been discussing, they're based on data and research from cognitive market research.
Absolutely. And maybe a final provocative thought for you to consider. As these materials continue to evolve, get smarter, more capable, how might they fundamentally change the very nature of the products we use every single day, making them not just stronger or lighter, but maybe truly smarter, more adaptable, more responsive to our lives? And in turn, how might that completely reshape the entire industrial landscape?